Thanks everyone for joining today. Today I'm going to be talking about this weird concept that we call application stability management, and why what you're used to doing, probably in monitoring your application stack and your infrastructure stacks, maybe isn't the right thing to do for modern application stacks, especially on the client side. So who's this guy with the British accent? I'm James Smith. I'm the CEO and co-founder of Bugsnag. I've been in startup land for 12 years. Before then, I worked building trading platforms for Bloomberg, and I worked in embedded software, and used to dabble on building open source projects and software. Back in the day, my Android library, Android async HTTP used to be pretty popular. Don't use that these days. There's much better ways to do asynchronous HTTP on Android. But these days, I think my team would describe me as a retired software engineer. I don't get to code much anymore. And these days, what I'm working on and building is a company called Bugsnag. And Bugsnag, as you probably guessed from the title of this talk, we provide an application stability management platform. And I'll dig into what that means in a minute, but the idea behind our product, our company in general, is software breaks. When software is broken, it costs a lot of money, not only in terms of things like lost revenue, but your development team's going to get pissed off and not want to necessarily be spending their entire life on bug fixes. And so we kind of set out to solve that problem, or help solve that problem, by helping you figure out where the problems are in your application, what the likely cause is, and steps to reproduce, and give you an idea of how to fix it. And we do that on pretty much every part of the stack. If you have a backend application in Java or Python or Ruby or PHP or whatever, we support detecting errors automatically in that part of the stack, but also all the way through to the client side. We have customers who are TV streaming applications, and you'll see, if you have a TV streaming application on your television, probably Bugsnag's in it. We also have desktop applications that we support, mobile applications, web client applications. But the idea is, if you've got software, we'll detect bugs in it, and we do that a lot. We've got over 10 billion application sessions per day that we monitor for bugs. And we do that for a lot of companies. We do it for little SMBs all the way up to massive companies like Shopify and Lyft and Airbnb and Pinterest. And again, if you've got some of these applications on your phone, probably Bugsnag is monitoring the health of these applications. You'll notice as well, not only just tech companies that I kind of reeled out, but also non-tech companies who have software, which I think it was Mark Andreessen a few years ago said that every company is now a software company. Basically, if you have a software team, a tech team, an engineering team, and you're trying to differentiate via technology in some way, provide value to your customers via technology, probably that means you're going to introduce bugs. So you see Darden restaurants, Olive Garden down the bottom there. When you're getting your unlimited breadsticks, hopefully you're not finding unlimited bugs, because Bugsnag's helping people who find and fix those bugs. So I kind of went over the verticals there, all the types of companies that use Bugsnag, and this concept of application stability management. But why is this a thing? Why have these companies adopted this? Well, software now gets pushed more frequently and more rapidly than ever before. I mean, even zooming out from that for a second, software development today is very different to software development 10 plus years ago. Most startups and modern companies have already adopted a lot of these techniques, but even the kind of crustiest technology teams that I've spoken with and work with are adopting these things or seeing these problems themselves, because, like I said earlier, any software you build is going to have bugs in it, and everybody wants to do the new best practices and approach their customers in new and innovative ways. Anyway, it used to be that you would get your software done, get a gold master version, press it to CD or DVD, ship it to Best Buy, and then hopefully your customers would pick up a copy of Windows 95 or whatever it was, Microsoft Office, in store, use it and enjoy it. But these days, obviously, that's not how software is delivered. Everyone's kind of moving to more rapid iteration cycles and agile development, CI/CD. They're doing this because we want to give features and functionalities to our customers sooner and quicker. If we can get these features out live in the hands of our customers as quick as possible without screwing up, that's the sweet spot. It also used to be that there was a game of hot potato that happened during software development. At the beginning of my career, and this still happens in a lot of companies I know, it used to be that the product team would do a product spec. They'd toss that hot potato over to the development team who build the code. Then the development team would toss that hot potato over to the QA team, and maybe the QA team would find some bugs, toss them back to the development team, and do a little bit of a dance there back and forth for a while. And then eventually the software was done and you'd give it to the operations team to run the software, make sure it was up and available. Early in my career, I wrote a service that was processing a lot of transactional volume and went on PTO, went on holiday. When I was sat on the beach, had my phone off, didn't take my laptop with me, came back 10 days later and my service was down. There was a bug in it that caused the software to not work anymore. Now, back then, they just shut the service down and rolled out the old version of the software and kind of told the customers, sorry, we can't fix it, which was ridiculous. You wouldn't see that happen anymore. These days, you want things to be more owned end-to-end, but the people who tend to own the software back in the day used to own it and then hand it to someone else. These days, there's almost a full cycle ownership that exists. I'll talk more about that in a minute. Also, another trend is previously people used to care about monitoring in terms of performance and spend. Spend is interesting when it comes to monitoring, especially APM. Historically, I'll talk more about this in a second, but historically, people would adopt tools like AppDynamics, New Relic, and other APM providers as a way to optimize cloud spend. Yes, there's other benefits to it. You want to understand your performance characteristics of your software. But the real ROI driver that got the procurement team and the CIO, CTO to sign off on this purchase was, hey, if we can reduce our CPU usage on this key part of our software by 25%, we don't need to have as many cloud instances spun up, which means we can reduce our cloud spend by 25%. Today, that's obviously important, but that doesn't necessarily make sense on client-side applications. You know, when you were doing a web application that was completely server-generated, a Ruby on Rails, PHP, Spring application, you cared about those cycles a lot. But actually, there's a whole separate part of this now. The client side is involved. More and more business logic and code is being pushed to the client side. Obviously, 10 years ago plus, mobile development and smartphone applications became a thing. So more and more code ends up on your phone. There is no cloud spend on your phone. It's a different question that you're trying to answer. You care about performance because you care about customer experience, not cloud spend. And the kind of monitoring side of things, infrastructure versus application centric, I already talked about that a little bit, but because the ownership is different and because hopefully software development teams care more about their code for the full cycle of that code rather than just tossing it over the fence to the operations team, monitoring needs to be more application centric. So, you know, this is, hang on a second here, skip to the next one here. There's kind of benefits to this, right? The point is you're trying to get software in the hands of your customers quicker, but faster software delivery causes more bugs. Obviously, bugs cause problems to customers and are expensive. And you need to know where these bugs are and which ones matter, candidly. If I was at real IRL DeveloperWeek, my team would probably have a booth. We'd all be wearing our t-shirts that said, not every bug is worth fixing. And that's what I'm talking about here. So where do you go to figure out customer experience? Where do you go to figure out which bugs matter more than others? Well, that's kind of where stability management comes in. Yesterday's source for insights isn't necessarily the right place to go. This is why. And I've talked about this a little bit already, but APM products, their root is in the backend. It's not in the client side. It's not in the customer-centric side of things. So why does that matter? Well, the closer you get to your customers, the more you're mirroring the customer experience, and you're understanding the customer experience. I already talked about figuring out application load times and cloud spend and all that kind of stuff. But one thing that's worth pointing out is the audience of these products. APM products were designed for the world where you would toss your software over the fence to the infra team. And so the people who care about these the most and spend most time in APM products are the SREs, your DevOps teams, your infrastructure engineers. And that's fine. These products are great for those people. We work with a large e-commerce company that has thousands of developers using our product. All of those developers have a login to Bugsnag. Only about 2% of them have a login to their APM provider. And that's because it's not designed for them. No matter how much these APM providers say we're developer-centric, they're not. So this is kind of the issue. You want to understand the performance characteristics of your software. That's fine. But does that matter so much? You care about knowing when your servers are down. You care about knowing when you've rolled out a particularly non-performant piece of software. But also APM helps you with things like capacity planning. When do we need to scale our cluster? When do we need to buy more cloud infrastructure? So because it's designed for infrastructure teams, typically, it does a very good job of helping you figure out these kind of problems. But we say this all the time. What's the point in tuning your engine if your vehicle has flat tires? And I think the flat tires of the past used to be availability, right? You've heard of the 5 nines of uptime and availability in infra world. Really what they help you focus on is, our servers are down, or our system stack is down. That's a flat tire. Tuning the engine to get that little bit of extra boost out of it, putting some NOS in the tank, is really a different concern. If your tires are flat, what's the point in tuning the engine? But I think that uptime and availability is mostly something that people already care about, something that people have been caring about for 20, 30 years. Because guess what? That mattered in the old way of building things as well, in the way of building web apps that were generated from the server side. So with all those trends and all those things that have changed, how should we think about it these days? Well, you can tell that I'm a big fan of these pyramid diagrams here. The way that application stability management thinks about this problem is focusing solely on stability. This is the other type of flat tire. And this type of flat tire matters no matter what part of the application stack that you're on. If you are running a backend application and you have an exception that causes a 500 error for one of your customers. If you are running a desktop application that crashes. If you're running a mobile application that crashes, if your television application crashes, which unfortunately these days with smart TVs, you will see these crashes happen. That causes your customers to have a session-ending event. It means that they're not able to use the product. It means your tires are flat on your vehicle. So this matters at every part of the stack, and it is worse than a slight slowdown most of the time. So what does that mean? Focusing on stability means starting from the customer experience. Is the customer able to use the product? Are they having a good time in the application? So let's start there. And what part of your application stack do customers touch first? It's the client side. The mobile and web application, JavaScript application layers of your application stack. And again, uptime and availability monitoring doesn't make sense for a mobile deployed application. Your app is on someone's device already. It's working, it's there. So are there crashes happening in it? And as we go deeper down the stack, you want to still discover these issues in the backend and API layer, in the database layer, and all that kind of stuff. But starting at the customer side means that you capture these customer experience issues in every part of the application stack. So that audience focus I was talking about earlier really matters. When you're building a stability management product like Bugsnag, you care about the stability of applications and releases and features from the perspective of software engineers, product teams, and eventually the customer. So the idea is you're meant to give the development team and the product team all of the tools they need to figure out, is this something worth working on? Should we even be fixing bugs right now? Is this something that we should pause our sprint that we're working on for the next feature in order to fix these bugs? Do they matter? So giving the full context behind errors, stack traces, user interactions with the application that led up to a bug, full diagnostic data, helping people figure out, should we be working on bugs or not right now? I'll talk about stability scores in a little bit. And developing strong customer experiences. So you can kind of see how this supports typical engineering team KPIs, release velocity. Maybe your product team cares more about app store ratings. Maybe your CEO is annoyed because your new app that you just built has a 1-star rating on the app store. Maybe you care about error rates. I talk about stability scores here, which are a Bugsnag metric, but maybe you care about error rates, and that's something you focus on as a KPI. So we talk about stability scores. Now, this is a metric that you get for free inside of Bugsnag. Out of the box, I mean, when you install Bugsnag's SDKs, we will tell you this. Now, what we do is we tell you what percentage of your vehicles have a flat tire. Well, effectively, we'll tell you what percentage of your customers or what percentage of interactions with your product were ended in a failure, were ended in a crash or a fatal exception or a fatal error. And we call that the stability score. In our product, we have two types of stability score. As I said, we have a session stability score and a user stability score. The kind of math that we have up there, the formula we have up there shows you the session stability score, the user stability score, sorry. What percentage of user interactions ended successfully? So the math's pretty straightforward. The definition of ended successfully maybe isn't so straightforward, which is why you need to define that, or why Bugsnag kind of gives you that out of the box. But the idea is not only can you say, what is our stability right now? Are we doing a good job? But you can talk about that in a way that matters and makes sense to the rest of your team. So you can say 2 nines, 3 nines of stability, just like you'd say maybe 5 nines of uptime and availability. And you can track that over time, and you can track that on a release per release basis. Like I said, when you're doing shipping software quickly, you want to kind of strike a balance between bug fixes and features. If you are shipping too quickly, you may miss your goals and miss your targets. If you are shipping too slowly, you may get beaten by the competition. They might release that feature before you do. So we'll help you figure out in an application stability management product, are we stable, and are we stable over time? What's the point in measuring that, though, unless you have goals in place? Now, this is true no matter what kind of metric that you have. But we follow in Bugsnag, our approach to application stability management is to help you set targets. And we use the SLA-SLO model, which if any of you have read Google's SRE book, you'll be very familiar with. But that helps you set 2 stability targets, not just 1. Believe it or not, setting 2 targets is often quite a lot easier than setting 1. The first target is target stability, the SLO, service level objective. This is an aspirational goal for your team. You're saying, if we are nailing it, we want to be at or above this line. And so maybe that's 3 nines, 4 nines, 5 nines of stability. The bottom line there is this critical stability line. Critical stability is your SLA, your service level service level agreement. This is the line when everything's on fire if you hit below this, and drop everything and fix it. So the idea here is we recommend to our customers, ride along that green line. It's okay to be above and below it a little bit, but ride along that green line. If you're consistently above that green line, it probably means you're not setting your goals correctly. It may even mean you're not striking a balance between bug fixes and feature delivery correctly. The benefit of having this data-driven layer for stability is you can know for a fact if you should be more or less aggressive about your shipping your software. Now, I hate using this phrase. There's this phrase that's quite often talked about these days in software delivery of testing in production. I hate that. I think it's an awful phrase, but I'm sure that a lot of you have heard of this phrase or maybe embody this phrase. I like to think of this more as progressive releases. So rather than getting your new version out to 100% of your customer base, can we give it out to a subset of our customer base? And maybe they're the people who are less risk averse. Maybe you've got a bunch of beta customers that want that latest feature today and are okay with a few crashes. Great. Well, do get the software in front of them and then measure your stability score over time in that beta environment. Once you've got that over time in the beta environment and you understand where it's at and improve it during that beta release, then you can push it out to 100% of your customers. A lot of companies are also doing this in terms of phased releases. The Google Play Store and the iOS App Store both have phased releases as part of their developer dashboards now. You can say, roll this out to 5% of my customer base, and then more over time. A lot of people are using tools and techniques like feature management or A/B testing and experiment tools like Split or Rollout or Launch Darkly. These all allow you to give certain subsets of your code base to certain subsets of your customers by turning on and off feature flags. This is another great way of saying, let's make sure that we get our features to our customers quickly, but let's not give them a crappy experience by doing that. So one of my favorite things about application stability management and application stability as a concept is it's a business driver. It's something that you can have an easy conversation between product and engineering teams on, especially if you measure something like the stability score. If you have a stability score, that's effectively a customer experience KPI. You are saying, what is our level of technical debt? You are saying, what is our level of customer experience? The level of customer experience matters not only to the engineering team, but also to the product team. And back when I was an individual contributor writing code, sometimes the product team would be really, really aggressive. I'm sure you've all been in this position where it's the last day of the sprint and we absolutely have to get this feature live and we're being really aggressive about pushing it live. But if you can talk to the product team in the same language and say, hey, product team, we're not going to do this. We're not going to get this new feature live. And here's why. Because we do not want to give a poor customer experience, because our stability score, for example, is not meeting our SLA. We need to improve that. One of our customers actually used this in a board meeting. A major company that was releasing a new feature that the board was very, very excited about went to the board meeting and told the board, we're on hold. We're not going to meet our deadline for getting this feature live. And so here's why. We're not meeting our SLA for stability. And so I love that example because it's kind of the highest up you can possibly get when it comes to business drivers. If the board understands, the board of directors understands that you're skipping releasing a feature because you're not meeting your customer experience goal or your stability goal, then everybody is super aligned. I said earlier, bugs are expensive. You've got to strike this balance. I see it as a slider that you have to set between getting features live to customers and roadmap velocity and stability. Every company sets that slider differently, but the more you can get that slider adjusted just right, the faster you can give quality software to your customers. Now, if you're building a space shuttle, if you're building a medical device, you want to set that slider to the far left. You want that to be on maximum stability, and you don't want there to be any crashes in there. You're following all the safety critical rules and regulations and getting triple audits and all that kind of stuff. If you are a startup that's launching a brand new web app or mobile application that you don't yet know if people will like, you want to set that slider to the far right-hand side and get those features live as quickly as possible. Maybe there's bugs. That's okay, because you've got a bunch of customers or early adopters that are used to having flaky experiences because they really want to use your brand new piece of software. After you get to a sweet spot, you're going to slide that slide a bit to the left. You've got customers to support. You've got revenue to support. You want to be a bit less aggressive about releases. So look, this is a business driver. This is something that is a KPI, that is a language that can be spoken to throughout the entire layer of management and entire layer of engineering. So I'm going to kind of stop there. I'm going to throw out a little bit for some Q&A, and hopefully we'll get some Q&A discussion going on. Let's see. Got a question from Zaba here. Let me stop sharing my screen for a second. So, Xavier asked, why do you think application stability should be a KPI, and how does Bugsnag enable it? So, also, this is my special guest speaker today, Sherwin, my cat. He's just chilling over there, looking very relaxed. Application stability as a KPI, I kind of touched on that a little bit just now, but application stability is a very straightforward metric. It basically says, did our customers have a good experience, yes or no, and what percentage of them had that good experience? So I think it's very easy to understand. I think that anyone who is writing software cares about their end users' experience. I also think it's a easy to share metric. Stability as a customer experience reflector matters to the product team. It matters to the executive team. Stability as a reflection of technical debt matters to the engineering management team. And so it's very easy to align on. What we built at Bugsnag is effectively, you get this out of the box, right? You install some SDKs in parts of your application stack. If you're a mobile application, you install it via your package manager, or for CocoaPods for iOS or whatever you're using. If you're a backend application, you'll do Ruby app will do gem install, or you'll pull it in from NuGet. If you're a .NET application, whatever it is, we've got an SDK that detects how many sessions were there and how many bugs were there. It's not just the counters though. What we do is we detect each individual crash, and we'll take a diagnostic snapshot at that point in time. So the idea is, out of the box, you install these SDKs, and we'll detect the sessions, we'll detect the crashes, and we'll give you that stability score. What we can't do right now is tell you exactly how to set your targets and goals. That's absolutely a risk discussion that you have to have with your own teams. But can give you advice on what the industry is seeing. So we put out a report recently, the Application Stability Index report, that shows 99.4% or something like that is the average for mobile applications. So you might think, okay, that's not bad. 99.4% have a crash-free experience, but that's only 2 nines. The uptime and availability goals typically think about 4 nines, 5 nines, or more. 2 nines is pretty scary. It means that if you've got 99.4% application stability on mobile, that means 6 out of every 1,000 customers are getting turned away at the front door. And if that was your store, if you were an e-commerce product, maybe you've got a real physical store. If the manager was turning away 4 in every 1,000 customers because, I don't know, they didn't have enough staff or they couldn't let you in, that would be a pretty poor experience. So yeah, I think it's a KPI because it's easy to understand. It aligns product and engineering teams. It helps you innovate quickly without too much risk because it's a data-driven loop. And Bugsnag enables it out of the box with SDKs because it detects these at runtime in customer deployed applications. Another question here from Aria. Hopefully I pronounced that correctly. What differentiates Bugsnag to other APM tools? So I kind of talked about this briefly earlier with those magic pyramid diagrams that I showed. We focus on a different audience. We focus on development teams and product teams and release managers. And really what we're doing is we're helping people replace old school QA techniques. You know, I like to say that QA is dead, long live quality. We're helping people figure out actually how to work on and fix these bugs. Fundamentally, the actual features in our product that help you help target that different audience are mostly around things like prioritization. So as I said, the APM products in the space typically were designed for DevOps teams and SRE teams and infra teams. And it really shows. When you open those dashboards, you'll see average performance over time and even which servers are up and available and all that kind of stuff. What Bugsnag shows you is what's my overall stability of each application, and then which bugs are happening the most and which bugs are the most important and expensive. Then we show you what was the line of code that caused that bug and what are the user interactions that led up to that bug. But that kind of prioritization aspect, I think, is the key part that massively differs from the APM providers. If you are an engineer or an engineering manager, you are almost certainly running your week with sprints or some kind of other time-based iterative approach to building software. And you're probably planning those sprints 1 week, 2 weeks at a time. And that's where you say, this is what we're going to be working on right now. In order to plan those sprints, you're probably using something like Jira, and you have to set priorities. Now, Bugsnag, because we detect crashes, bugs, errors in customer deployed applications, we capture a diagnostic snapshot, and what we can do is we can fingerprint each of those crashes and those bugs that are coming back. What I mean by that is, let's say you launch version 2 of your application, and there's a bug, and that bug affects every customer. Traditionally, you would see in logging systems, for example, you would see 1 million different log statements. In Bugsnag, what you see is one bug happened 1 million times, impacted 900,000 unique users. Immediately, we're able to say this stream of data coming in maps to something you need to fix. It's a bug. It's a unit of work. It's something that you're going to fix in plan as a ticket in Jira. Our product not only shows you which bugs happen the most, we also have segmentation capabilities. We'll tell you which bugs happen the most in a subset of your customer base. For example, you can say, show me the bugs affecting paying customers the most. You can say, show me the bugs affecting my $1 million accounts the most. You can say, show me bugs affecting this key area of the code base the most. So if you are the owner of the payments page, for example, you can say, I care a lot about the experience for the payments flow. I want to see all bugs in the payments experience, because we have a full stack trace. We can tell you if you went through that part of the code base, and say, this is the bug that affected the most people in the payments experience. We're able to tell you, did this bug happen in a particular A/B test or experiment? Was this bug introduced in a new release? So the idea is here, we're able to group all of those stream of errors, exceptions, into a unit of prioritizable work. One other thing to point out is that because we focus more on the engineering team and the product team than classic APM providers, we're able to deeply integrate into workflows. So most of our customers will use Jira or some other a project management issue tracking tool. In the Jira example, Bugsnag actually has a two-way synchronization with Jira. If you create a Jira ticket from Bugsnag and then mark it as fixed and done in a sprint in Jira, if Bugsnag then detects that bug has happened again in a future release, in a new version, we will automatically reopen that Jira ticket, mark it as a regression, and say, hey, I know you told us you fixed this, but you didn't. We found it again in a new release. So it provides this kind of data-driven feedback loop to what you're doing in your engineering team to make sure that you're focusing on the right stuff. We can even, now with what we call our alerting and workflow engine, automatically create Jira tickets when errors happen matching a particular segment or happen above a certain threshold of frequency. You can say, if bugs happen to more than, if a bug happens to more than 10 customers per day in our payments flow, automatically create a Jira ticket. And again, keep that linking between the two. We link to Slack, we link to PagerDuty. Every part of the development lifecycle, Bugsnag will automate and give a feedback loop too. So very long answer to a short question, Aria. Hopefully that gave you a bit of a taste. But we've built this for development and product teams rather than infra teams. And every part of the product is designed to fit into those workflows. Does anyone else have any further questions? I'm happy to stay on for a while and answer some more questions. Awesome. I've got a question from Ivan here. How are users and sessions defined for the stability score? Are they editable based on the use case? Good question. So when we're talking about the stability score, you saw there was the bottom of the fraction, right? There's the number of what percentage of sessions or users were crash-free or bug-free. So that bottom of the fraction is the session and user data. Now, because we're a full stack solution, we support mobile and web and desktop and backend. The definition of sessions varies depending on your platform, but I can give some typical examples of how they're default defined. On a backend web application, we detect a session as a web request. So we can tell you what percentage of web requests were successful. On a mobile application, we detect a session as an interactive foreground session in your mobile application. So was the customer interacting with your mobile application, and was that application in the foreground? Now, one of our product philosophies at Bugsnag is to be opinionated yet extensible. And what that means is when you install the SDK, we're going to give you a stability score out of the box, and we're going to detect that based on the defaults for sessions that I've just described. But every application and every business is different. You may be an application where most of the application sits in the background. Maybe you're Spotify and you're playing music in the background. You might want a session to mean something else and align with other internal metrics of sessions, because probably you're defining a session for analytics purposes anyway. So Bugsnag also allows you to do disable the automatic session tracking and effectively do start, stop, and pause session depending on particular lifecycle events that are happening in your code. So it's very opinionated out of the box, and it works for 99% of customers. But if you want to adjust that, you absolutely can. Hopefully that answers your question. Odogene, again, apologies if I pronounced that wrong. How would you describe the developer's role in maintaining application stability? So I'm very opinionated on this. You saw earlier I was talking about trends. It used to be that you toss things over the fence and it would be someone else's problem once you built the software. And I think that was the worst thing that ever happened to software development. I think that as a software developer, you should treat, I mean, this is literally Etsy's blog name, isn't it? But you should treat your code as a craft almost. I'm not talking about artisanal, organic, handcrafted code. I mean, you are building something. You should take pride in what you're building. And so it's kind of a matter of fact these days that you are going to see your code again. After you deploy that to your customers, you're going to see it again next week. You're going to have a bug in it. You're going to change it. But 10, 15 years ago, once you wrote it, maybe you'd never see that code again. But now, if you can get feedback on your code and understand, is it causing any problems? I think you should care about that as a software developer. It shouldn't be someone else's job to triage this. It should be your job to care about your code. And so I'm kind of starting at the low level here, which is how should developers care about the bugs? Well, I think that developers should care about bugs in their code so that they can get better as software developers. I remember this when logging was really the only option, where you used to be able to dig into your log files and I'd be able to say, uh-oh, that was a problem. I'll make sure not to do that again. I'll make sure to protect against uninitialized variables next time. But if you're using a tool or product like Bugsnag and it's showing you these things grouped together, this is something you can look at as an individual contributor. You can say, look, I'm making loads of method not found exceptions or uninitialized variable bugs here. This is awful. I need to get better at this. Also, potentially, you can share that with your manager and say, hey, boss, in my one-on-ones, can you help me with this? Or you can share that with your testing team and say, I have a habit of letting these kind of bugs slip through the cracks. Or as us as a team have this habit. Can we update our testing process to put some more static analysis in to catch these types of bugs? To the higher level question, what's the role of the developer in maintaining application stability? Well, I think that if everybody has access to this data, like in our Bugsnag dashboard, we'll show you the stability score for every app in your stack. Maybe you can be the one that drives change in your business. So I like to think of application stability being a empowering metric for conversations like technical debt. If you're a developer, you innately understand this. You understand, oh, I don't want to work in this code base. This is a crappy code base to work in. It's old, it's buggy. I don't want to be in here. But maybe you'll have difficulty in communicating with your boss or with the product team to say, we need to refactor this because there's a lot of technical debt. Well, maybe you can use the stability score to say, here's the evidence of the customer experience being impacted. I can see that that's happening in this part of the code base because I'm looking at the number of errors in Bugsnag. If we fix these bugs, it will give us a better customer experience. So rather than kind of being the person who's complaining, moaning about technical debt, I've been that guy. Oh, this sucks to work in this code base. You can say, this is the evidence. This is how customers are being impacted by this in production. So I think that the developer's role is triage and fix bugs in the areas that you own. But I think that actually the developer's role is also to understand what stability means for your customers, and use that as a metric for having business level conversations around refactoring or roadmap velocity and things like this. It shouldn't be something that the boss just decides. I think it should be something that empowers individual contributors as well. Juice says, I assume that my code is being used by the less intelligent people in the world. Well, I'll tell you what I find quite funny. Sometimes that I've written some code in the past, and then a year, 2 years later, I come back at the code and I'm thinking, what idiot wrote this? And then pull up Git blame and realize it was me. And so I think the less intelligent people in the world might be me 2 years later when I don't understand what the heck I was doing 2 years in the past. But I totally get you on that. Yeah, we've got a few more minutes left. If there are any other questions or fun areas that people want to dig into, I can stick around for a little bit longer. All right, maybe we can wrap up a little bit early then if there's no further questions. I'll do a little bit of a plug at the end of the session here. I talked about Bugsnag as an example of application stability throughout this talk. You know, we've built this product to solve this problem, and so you don't have to roll your own or build your own thing here. And we built this product for development teams, not for infra teams. Infra teams use it, but it's designed for that audience of software engineers and product managers. So if you want to check out Bugsnag, you can go to bugsnag.com. We have a free trial. You can kick the tires on it. We have a free plan as well if you're a hobby project or a low volume application. If you're a larger business, a larger company, a lot of our customers are enterprise customers these days. And so if you want to kick the tires on the free trial, you can. If you want to request a demo, you'll get one of our team walking you through a demo of the product and talking you through how this can help your organization. But yeah, what was I going to say? Come and join us in our virtual booth. Come and say hi. And apart from that, you can find me on Twitter. There we go. Thanks, Amanda. Amanda's telling you more about what to do next. Come and watch some videos about the product. Come and talk to our team and get our super soft, comfortable t-shirt that says, like I said earlier, not all bugs are worth fixing. I should have worn it today. What am I doing? Not advertising well enough. But thanks for joining. Thanks for coming along. And I'll stick around in the booth for a little bit afterwards as well to say hi. Thanks, everyone.